All right, today we're going to continue talking about graphing, and we're going to use probably everybody's favorite form today, which is called slope-intercept form. We're actually going to skip over graphing using the x-intercept and the y-intercept just for the sake of time, because they don't want us having you spending more than half an hour on your screens every day for math. So, but I do want to go over actually. So you're going to see different forms of a line. Okay, so you're going to see equations that are written like this, like 3x plus 5y equals 6. Okay, that's one way to write an equation. Another way to write an equation is to get the y all by itself, like down here. And this is called, right here, this is called slope-intercept form down here. This right here is called standard form. So standard form is basically where you have some number in front of the x, and then, some number in front of the x, you have another number in front of the y, and then that's equal to another number. So basically, the numbers in this case would be like 3, 5, and 6. Those should all be numbers, and then the x and the y should still be letters. So those should still be x's and y's. So that's called standard form. Okay, you'll see that a lot. This is a really common way to write the equation of a line, and there are many scenarios where it makes sense to write it like this. Today we're really going to focus on slope-intercept form though. So slope-intercept form is really nice. What you do is you get the y all by itself, and then your job is to figure out what the m and what the b are. They should just be numbers, okay? So like see in this case over here on this one where you have 1/2 x plus 3 over here. So that's called slope-intercept form. And what's cool about this is that the slope is just this number in the yellow, and the y-intercept happens to be this red number here. So the y-intercept happens to be this red number. Okay? And here's another specific example. Your slope here would be -3, and your y-intercept would be -2. So we're going to go over and talk about how to graph these. So this is a good thing to remember, though. So standard form is where you have the x's plus the y's, and that's equal to a number. And then slope-intercept form is where you have the slope times x plus a number, and that's all equal to y. You get y by itself. So we're going to actually skip over like this part right here, so we're not going to look at that. And we're going to skip over this part. I do want you to come down here, though, to the graphing by using slope-intercept form. It's on the second page of the notes there. Okay, so, and just like our notes say here, this is probably the most common method used to graph linear functions. Okay, so what we're gonna do is we're gonna see a question like this: 2x plus 3y is equal to 12, and this is standard form right here. Okay, so standard form, and what we're gonna do is we're gonna get it into slope-intercept form. And in order to do that, our first step here is to solve for y. So our goal here is to get this y all by itself. So before we graph and worry about graphing, let's just solve for y here. So if you were going to solve for y and you wanted to get this y all by itself, what would you need to do? If it was me, I would subtract 2x from both sides. When you do that, 2x minus 2x is nothing. You have 3y is equal to, and just because I know that I'm trying to get, some number x plus some number at the end of this thing, I'm going to put the minus 2x out in front. You could write 12 minus 2x here if you wanted to, but I'm going to do -2x plus 12. Because I know at the end we're going to want, our goal right now is y equals something x plus something. Like that's what we're aiming toward right now. And we're pretty close here. The only issue here is that 3 right there. So, okay. So now what are we going to do? We're going to divide both sides by 3. And make sure when you divide both sides by 3 that everything gets divided by 3, especially if you have a plus or a minus right here. So, okay. When we divide by 3, 3 divided by 3 is 1. So that basically cancels. So you're left with y is equal to, and now this becomes -2/3 x plus, and then 12 divided by 3 is 4. Okay, so what we've done here is we've taken something that was in standard form, that line was written in standard form, and now we've changed it here to, this is called slope-intercept form. You ever think of why we call it slope-intercept? It's because here's the slope and here's the y-intercept. So it's just really creative names that we come up with as mathematicians. Okay, now that the function is in slope-intercept form, identify the slope and the y-intercept, then graph. Okay, so again, just to reiterate, this is your slope right here. and this is your y-intercept. So what is a y-intercept? A y-intercept is the point where your function, like the line or the curve, whatever you draw, intercepts the y-axis. Remember, the y-axis is right here. So the question is, where does it cross the y? It would intercept means to cross, okay? So where does it cross the y-axis? So what it's saying here is it's saying, hey, the y-intercept is 4. So let's put in orange here. Where is the y value 4 on the y-axis? It's right here, okay? So we're going to start here. So that's our first point on our line. And then our slope tells us over here that we are going to go -2/3. So you may remember, hopefully you remember from last year with slope. Let's do it in red here. Slope is equal to the amount that you're rising divided by the amount that you're running. So in other words, it's the up or down over how far you're going to the right. Okay? So what this is saying here is it's saying -2/3, which we would translate as down 2, right 3 for this specific slope. So what we're going to do is I'm going to kind of count here down to right 3. And then what I would do is I would put my new point right there. Now you don't really need to draw the steps, the down and the over. I just am doing that to visualize it for you. So you're going to come down to right 3 from your original point. So you have to start up at your original point here, your y-intercept. So you're going to come down to right 3. And then what's nice about this is that this is the slope of the entire line. So you can keep doing this. You can come down to right 3 again and put a new point there. So you can put a new point there, down to right 3. And then if you're going down to right 3, you can also go up to left 3. So what I'm going to do here is I'm going to take this point, go up to left 3, and put a new point right there. Yeah? So up to left 3, up to left 3, up to left 3. And now we have a nice line. So we're going to go ahead and connect that line. And we have graphed the line here. And this, I don't know about you guys, but in my opinion, this is my favorite way of graphing. It's just super easy. You find the y-intercept, you plot it, and then you go up to left 3, down to right 3, and that's it. Okay, so let's do it. We're going to do a few more things here before we let you go. I want to make sure we're all on the same page about slope. Okay, so slope, this is just our definition here, is a number. Okay. It drives me nuts. Like next week, I'm going to ask you guys, like, hey, what's the slope of what's the slope on this line? People are going to be like 2/5 x. It's like no. The slope is just the number in front of the x. Okay, so for example, the slope here is not -2/3 x. The slope is just -2/3. You don't need to include the x in it. Okay, so don't say x when I ask you for the slope. Okay. So slope is a number typically written as a fraction that measures how much we have to go up or down divided by how much we have to go left or right to get from one point to another on the line. Okay? It's essentially a number that compares how much the y values change versus how much the x values change. So yeah, that's what slope is measuring. It's just measuring like, hey, what's your change in x values versus your change in y values? And that gives you an idea of how steep your line is. Okay. So you might have seen it before as like rise over run. Some people like to say that. You might see it as up and over. You may have seen this little formula, y2 minus y1 over x2 minus x1. Those are all great. Just trying to jog your memory here. Okay. So what I want to do here is I literally just want to plot some points and then make sure we're on the same page about what's the slope between these 2 points. Okay. So let's plot, we're going to plot the points 2, 1. Okay. So this is always going to be my light blue point, okay? So 2, 1 is going to be my light blue point. That's kind of my point that I'm going to be going from. Okay, they want to know, hey, what's the slope between 2, 1 and 4, -3? So I'm going to put 4, -3 here in red. And we're going to determine the slope between these 2 points. So we're going to go from the blue point to the red point, okay? From the blue point to the red point. So what's the slope in this scenario? It would be down 1, 2, 3, 4. And then over 2. And I should say not over, but I should say right 2. So it's down 4, right 2. Okay? If you are going, by the way, if you're going up, you should be putting a positive number in the top. If you're going down, you should be putting a negative number in the top. If you're going right on the bottom, you should put a positive number. If you're going left, you should put a negative number. We're going to talk about that here in a minute, okay? So the slope between these 2 points is -4/2, or if you'd like, you can just call that -2, right? -4 divided by 2 is -2. Okay? All right, how about the next point? So -5, 3. So -5, 3 would be here. So what is the slope between the orange point and the blue points? I'm going to start at the orange and go to the blue. I typically go from left, whichever point is further left. So to get from the orange to the blue, to me it looks like we're going to go down 2 and then right 1, 2, 3, 4, 5, 6, 7. So down 2, right 7. So -2 divided by 7. So -2/7. That's the slope between those 2 points. All right. Let's see. Next, I'm going to do dark blue here. -4, -5. So -4, -5 is going to be over here. And the question is, what's the slope between these 2 points? So, I'm going to start at the dark blue point. So we're going to go up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6. So up 6, right 6. So 6/6. You could also just call that 1, right? 6/6 is 1. Okay, how about 6, 4? So 6, 4. 6, 4 is right here. That's in purple. What is the slope between these 2 points? So we're going up 1, 2, 3 over 1, 2, 3, 4. So up 3, right 4, 3/4. Next point, yellow, 2, 5. So 2, 5 here. So what is the slope between these 2 points? So I'm going to start at the blue. Up 1, 2, 3, 4, and then right 0. So it's 4/0. Now, if you try to punch 4 divided by 0 into your calculator, you're going to get undefined. It's going to be divide by 0 error. So we cannot divide by 0 in math. It's just kind of the way we say it, right? Like you can't divide by 0 for various reasons. I'm not going to go into them in this video, but if you want to know more, just ask me. Okay? So you can't divide by 0. So if you have a slope that's straight up and down here, it's going to cause you to try to divide by 0. So your slope's going to be undefined there. Now this is different from what we're going to do now. So we're going to plot this point here at 5, 1. Okay, so we have this point here. And what's the slope between these 2 points? So we're going to go up 0, and then we're going to go right 1, 2, 3. So our slope here is up 0. Right 3, and if you plug 0 divided by 3 into your calculator, you're going to get 0. So interestingly, the slope between these 2 points is 0, and the slope between these 2 points is undefined. Okay, so if you're ever having a sideways line like this, then that slope is 0. But if you ever have a up and down line, that slope is, we say it's undefined because you can't divide by 0. Okay, all right. So this is just what I was saying here. If you happen to find yourself going up between 2 points, like let's look at these 2 points right here. If I go up, I'm going to count that as +2. And then if I go right, I'm going to count that as +7. Okay? And actually that's 8 right there. Okay? So if I go the other way though, like if I go down 2 and then left 8, then I would count that as -2 over -8. So if you're going down, you count it as negative. If you're going left from one point to another, you count it as negative. Now what's interesting is that 2/8 and -2 over -8 are actually the same number, right? They're both 1/4 or 0.25. But it just depends on how you approach the problem and which point you start at. Okay? So just keep that in mind there. If you're confused by that, let me know. Okay, so when a line is horizontal, like this line right here, what's the slope here on this line? It's up 0, right 4. Okay, so that's 0. So if you have a horizontal line, the slope is 0. 0 divided by 4 is 0. If you have a vertical line, 1, 2, 3, 4, so we're going up 5 over 0, we say that the slope is undefined. All right. Let's graph a few more. If you feel like really solid on these and you want to just go do the delta math, please, by all means, go ahead and just go do the delta math. But I do want to do a few more examples for you here just in case you feel like you need them. Okay? So we're going to actually, let's tell you what. let's do these graphs right here, and then if you would like to see a couple more examples of the slope-intercept, I'll do that. So pay attention for this last part here, and then you can go do your delta maths. Okay, so what happens if you have an equation of a line that's missing one of the variables? So if you have something where it's just like, hey, graph y equals 3, they're asking you to show all of the points where the y value is 3. So I always ask students like, hey, give me some points where the y values are 3. So, and people just start yelling out numbers like, okay. So all of these coordinate pairs here, see all the y values? They're all 3 here. So, x is 1, y is 3, x is 2, y is 3, x is 3, y is 3, x is 4, y is 3. So when you do this, let's plot these. So 1, 3 is right here. 2, 3 is right here. 3, 3 is right here. 4, 3 is right here. You kind of start to see the pattern here. So if you ever have a y equals a number, what happens is that it makes a nice horizontal line there. Okay, so when you have y equals 3, it makes a horizontal line. Creates a horizontal line. And we're going to practice with these. I know I'm throwing a lot at you today. And then if we have x equals a number, like x equals 2, give me some coordinates where the x value is 2. So we say, all right, 2, 1, 2, 0, 2, negative 4, 2, 5. So let's plot all these points. 2, 1 is right here. 2, 0 is right here. 2, negative 4 is down here. 2, 5 is up here. So see what's happening here? Like if you keep making points, what's going to happen? You're just going to make a nice vertical line here. So what we do is we draw a vertical line here, and that's what x equals 2 looks like. Okay, so this creates a vertical line. Okay, in general, if x is equal to some number, this creates a vertical line. All right, so that's that. If you guys feel good about graphing in slope-intercept form, go ahead and work on that delta math. If not, I'll do a couple more examples for you here. So, okay, so now we've got, excuse me, 5y minus 3x is equal to 10. And again, the goal here is to get the y by itself. So let's add 3x to both sides. So we have 5y is equal to 3x plus 10. And then we're going to divide by 5 here. Make sure you divide everybody by 5. And you get y is equal to 3/5 x plus 2. Okay, so 3/5 x plus 2. So what we're going to do is we're going to start at our y-intercept here, which is 2. So I'm going to put that in orange. We're going to start at 2. And then what does our slope tell us to do here? So our slope tells us we're going positive 3 and then positive 5. So we would translate this as up 3, right 5. You shouldn't really say over 5, because over could mean left or right. We're going right 5. Okay, so we're going to go from the green point, or sorry, from the orange point, we're going to go up 3. So 1, 2, 3, right 5. Okay, so up 3, right 5. And then we're going to do it again from that point. So we're going to go up 3, right 5. And then we will go down 3, left 5, down 3, left 5. All right, so that's that one. And let's do this one here. Some of you are going to freak out because you're going to see f of x, but it's just the same thing as y. Okay, so this is saying, literally it's saying y equals negative 2/5 x plus 3. Okay, so f of x, y, it's the same thing. They're both the output, right? So like when you have a mapping, here's your x, here's f of x. You can also call these y. Like it's literally the same thing, right? And then you do the mapping. Okay, so when you graph this then, what are we going to do? So we're going to start at 3. So 3 is our starting point. And then what does our slope tell us to do? So our slope is negative 2 over positive 5. Typically, if there's a negative, I put it in the top part. Okay, so this means down 2, right 5. Down 2, right 5. Okay, so down 2, right 5. Down 2, right 5. Up 2, left 5. And then up 2, left 5. Okay, so that would be your line there. All right, let me know if you guys have any questions.